bro. What the heck? What's going on? Why is my camera like that? What's up with my camera? What's up with my camera? Okay, that's much better. It's working now. Alrighty. Yeah, we're gonna get rid of that. That is really loud. Work on a lesson. I'm not very far into this. Why did it lag so much when I did that?
Lesson 26, converse statements.
Okay,
So
that's really
far in
loud.
this chapter, when we've been working on proofs that involve parallel lines, we've always started with a given statement that says the lines are parallel. And then we've always had to prove that a certain angle pair is congruent, or maybe that the pair is supplementary. But we've always started with the information that the lines are parallel. That's been given to us as something that we should assume to be true.
By the way, I'm not gonna probably be able to read chat, but hi, what's up? How's it going?
But what if we
Oh,
have the
wait till
opposite
you eat your
situation?
eggs and bacon.
What if we know that two particular angles are congruent, but then we want to prove that the lines that form them are parallel? And let me show you an actual example of this.
Just a second.
Are you seriously recording yourself doing that? Oh my gosh, you have the light on and everything.
Light on? Hey, Dad. Yeah, but I use it for like other games too, dude. Okay.
So I'll put a picture up. See, our given statement says that angle 1 and angle 2 are congruent, and then we can see that those are alternate interior angles. And then we're supposed to prove that the lines L and M are parallel. Now, they look like they're parallel, but that's not enough in geometry or really in all of math. Remember, everything has to be proven using deductive reasoning. So this is actually the opposite situation from what we've been dealing with. Normally, we would start with the given that the lines are parallel, and then we have to prove that the alternate interior angles are congruent. You see, this is a little bit different. And it's really tempting to try to prove this statement that the lines are parallel by using our postulate 6. Let me refresh your memory and put postulate 6 up on the notepad. See, it says that if two parallel lines are cut by a transversal, then their alternate interior angles are congruent, or you can say the measure of the angles are equal. And then this does pertain to alternate interior angles, so it's really tempting to try to use this one to prove that these lines are parallel. But notice the way the postulate is written. The if statement up here says that the lines are parallel, if two parallel lines. And that means that we're assuming that that's true. The then statement then concludes that the alternate interior angles are congruent. And so this actually doesn't work. We need the opposite. We need this to be flipped around. We need to say if the alternate interior angles are congruent, see, that's what we're assuming here, then the two lines are parallel. And then here's the big question. Are we allowed to just flip this thing around and use it? Can we just switch the if and the then statement and then use it to prove that these two lines are parallel? The answer is no. And the reason is that according to the rules of logic, if we start with a true statement and then flip it around, the new statement does not have to be true. This is a really important point.
Hey, just a second. I'm gonna move this up to here. there. Okay.
And just to give you a simple example of this, let's look at another statement. We have, if a vehicle is an automobile, then it has four wheels. Now, this is a true statement, but now let's flip it around. The flipped around statement says, if a vehicle has four wheels, then it is an automobile. Is that true? Well, no, not really. Just because a vehicle has four wheels doesn't necessarily make it an automobile. It might be a truck or a Jeep, or it could be a lot of other things. So the
How are a truck and a Jeep not an automobile, though? Pretty sure those are also
second statement, the flipped around statement, is not true, even though the first statement was. And so this is why you can't just flip things around and then use the new statement to prove something. How do you know that the flipped around statement is right? And a diagram, a Venn diagram of these two will show the problem pretty clearly. Let me draw you a couple of Venn diagrams. See, when a vehicle is inside the automobile circle, then it has to be inside the four-wheeled vehicle circle. And then that's why this first statement is correct. That makes sense. If it's an automobile, it has to have four wheels. But just because a vehicle is inside the four-wheeled circle doesn't necessarily mean that it's an automobile, which should go in the automobile circle. And see, that's why the second statement isn't true. The second statement, instead of saying when you're in the small circle, you have to be in the big circle, the second statement, the flipped around one, says that if you're in the big circle, you have to be in the small circle, and that's definitely not true. An accurate Venn diagram of our flipped around statement, the one that says if a vehicle is a four-wheel vehicle, then it has to be an automobile, that would look like this. And we know that isn't right. Just because the vehicle has four wheels doesn't necessarily make it an automobile. So see, that's the difference.
Okay.
The first statement was true. The one that said if a vehicle is an automobile, then it has four wheels. The second statement, if a vehicle has four wheels, then it's an automobile, is false. And the main point is that you have to be very careful about flipping a statement around. It changes the meaning. And if the original statement is true, the new statement doesn't have to be true. It may very well be false, like this example. And so we cannot just flip around pop.
Just a second.
Postulate 6. Remember, postulate 6 was the one that said that if two lines are parallel, then the alternate interior angles have to be congruent. You can't just flip it around and use that to prove something. When we flip a statement around by switching the if part and the then part, we create something called the converse of the original statement. So the converse of if a vehicle is an automobile, then it has four wheels, is if a vehicle has four wheels, then it's an automobile.
Okay.
And you may remember from chapter 1 that conditional statements, if-then statements, can be shown in symbols. When the if statement's represented by the letter A and the then statement by the letter B, the whole...
Just a second. I'm going to see if there's like a list of these postulates online, because I don't have them memorized. Okay. It appears that there is a list.
whole statement can be shown really short, in a short and quick way like this.
I don't know what to download.
A and an arrow pointing to a B, and it means A implies B. And so that's nothing new. We covered that quite a while ago. But we can actually use these symbols to show the converse of a statement. If the original statement is A implies B.
Just a second. I'm going to try to light this. Oh gosh, that's not what I meant to do. Light this up a little bit. Is that working? Yeah, I'm lit up more. Okay. Sorry, I'm getting
Then the
distracted.
converse has to be B implies A. And that's because the converse is just the same statement, except the if statement and the then statement are switched around. I would say the most common logical error that people make is that they assume that if a statement is true, if an original statement is true, then the converse must also be true. People make that mistake when they're making arguments all the time. For instance, someone might make this sentence as part of an argument. They might say, all good citizens believe in democracy, and Mr. Jones believes in democracy, therefore Mr. Jones must be a good citizen. And it sounds like the person is just making a very logical argument, and the conclusion has to be true. It sounds like deductive reasoning. But then if we write these in if-then form, look at what we've got. If a person is a good citizen, then he believes in democracy. And then the conclusion was, if Mr. Jones, a person, believes in democracy, then he's a good citizen. See, this statement and this statement are the same, except the second one is just flipped around. See, the if statement here became the then statement.
So wait, are these both valid? I don't think that one implies the other here.
And the then statement here became the if statement. And so the argument that was supposedly deductive reasoning and so logical is really just saying if the original statement is true, then the converse has to be true. We know that's not right. The converse doesn't necessarily have to be true, even though the original statement may be. Now, another way to tell whether this kind of reasoning is valid or invalid is to draw a Venn diagram. And of course, we've been doing that for quite a while. And you can tell like that. But now you know why the reasoning in this example is invalid. It's because the person's trying to argue that the converse of a statement that's true has to be true as well. And that's not right. Now, there's one case when the converse of a statement should also be true. And that's when the original statement is a definition. And remember, the test of a good definition is whether it's reversible. And just to refresh your memory, let me put up an example of a definition and then show you the reversed version. Here's the definition. A transversal is a line that intersects two or more lines in different points. And then now here's the reversed version. A line that intersects two or more lines in different points is a transversal. And this definition is good because after reversing it, we have a statement that's still right. Because this makes sense, and you could cover up the word transversal and you would know what goes in that blank. There's enough information in the beginning to tell. But now let's look at both of these statements in if-then form. In if-then form, the original goes like this. If a line is a transversal, then it intersects two or more lines in different points. And then here's the reversed version. If a line intersects two or more lines in different points, then it is a transversal. It's pretty clear that this reversed statement is really just the converse of the original. So a good definition is actually one where both the original statement, the original definition, and its converse are true.
Okay.
You've been doing a lot of problems like this for quite some time where you take a definition and you apply the reversibility test, you flip it around to see if it still makes sense. All you were doing.
So I'm going to write this down. Should still. So, okay, I'll be able to remember that through the lesson. Can y'all see that? Y'all can kind of see it. Not very well.
Was taking the converse of the definition and seeing whether the converse was right. And if it was, then the definition qualified as a good one. You just didn't understand the technical word converse. And then if we wanted to make this point by using symbols, we would say this. For any good definition, A implies B, B implies A should also be true. Because the converse of a good definition should also be true, a lot of times definitions will include both the original statement and the converse. And let me give you an example of that. The definition of a transversal could actually be written like this. If a line is a transversal, then it intersects two or more lines in different points. And if a line intersects two or more lines in different points, then it is a transversal. Now, the only problem with showing a definition like this is it's really long. A shorter way to write the same thing, though, is to do it like this. A line is a transversal if and only if it intersects two or more lines in different points. This means the same thing as the long version that I just had up. It means the original statement and the converse. That's what if and only if means. And then to shorten this even further, a lot of people abbreviate the phrase if and only if. They write it like this, IFF. And so if we wanted to use this abbreviation, then this version would look like this. A line is a transversal if and only if. You would go ahead and say it all out, even though it just has IFF. if and only if it intersects two or more lines in different points. And that means the original definition of a transversal and the converse. I had them both up here a while ago. And so if you see IFF, that's not a typo. That's not just an extra F stuck in there. That means if and only if. And you know the reason for it. It's to show that both the original definition and the converse are true. So it's a good, solid definition.
All right.
And then one last point about if and only if. To write something like this in symbols, it would look like this. A and B, but instead of an arrow going toward the right, the arrow would go both directions. And so this means A if and only if B. And we could just write it as AIFFB. That would work too. Now let's go back to the proof that we had at the beginning of the lesson. Remember, our given statement was, here it is again, angle 1 is congruent to angle 2, and then we're supposed to prove that lines L and M are parallel. Now, to actually complete this proof, we need to...
Okay, wait, I'm going to see if I can do myself. So, prove that L and M are parallel. Given that 1... What does that thing mean? Guys, what does this thing mean right here? I'm literally, I'm looking this up. The, and squiggle? Where is it? Approximately equal to. Okay, well, that's the same as equal to, so it's not helpful. It's equal because this, if these two are equal and they're alternate interior angles, the frick? I'm not recording. I'm trying to figure out if, yeah, they're, yeah, okay.
use the reason, let me write it up here.
Don't mess with, hey!
If
Hey.
two lines form congruent alternate interior angles with the transversal, then the lines are parallel. That's really what we need because the if statement
No
has
way.
to be that the angles are congruent.
Imagine your mom. Oh gosh, now this is probably messed up.
And in the conclusion, the then statement has to be the lines are parallel. We can't use postulate 6. Remember, we were tempted to use that, but it's wrong because it's assuming that the lines are parallel and then concluding that the angles are congruent. And this is actually the converse of postulate 6. But by now, you know that we cannot automatically assume that this converse is true just because we're assuming that postulate 6 is true. That's a logical mistake. Actually, it turns out that this is true and can be proven using deductive reasoning, but the proof involves some concepts that we won't be covering until later on in the book. And so what we're going to do is just accept this as another postulate. We're going to assume that this is true, but we're going to have to call it a different postulate because it's not the same as postulate 6. This will become our postulate 7. And so to finish this proof, we would have to use postulate 7, not postulate 6. So it really matters what's your if statement and what is your then statement. What are you assuming and what are you concluding? And that's really the key point of this entire lesson. A statement and its converse are two different things. If one is true, the other may be false. You have to be careful. You can't use the two interchangeably.
Yes.
From this given statement, you need...
Why does the recording sound so much better like in the actual problem? I don't understand that. Makes no sense. Okay, just a second, because my trackpad is nasty. So, my trackpad is absolutely disgusting, so we're gonna wipe it off. Ooh, right in the trash can. That one didn't even make it close, but whatever. Okay. Proves that L and M. Okay. So this is supplementary to this, it looks like. And this is equal to that, so that's also supplementary. So it's gonna be, what on earth? What I'm looking for is not even in here. If two lines form congruent. Is that right though? I'm gonna click go, but it's
That's right.
ooh, let's go. Okay.
Given that segment QS is
frick.
parallel to segment PT and segment SP is parallel to segment TR, you need to find X in this figure.
Oh gosh.
Notice that the 2x degree angle and the 102 degree angle are alternate interior angles.
Oh.
So use that fact to set up an
Okay. So are they really though? They don't look the same. I guess they are though. They are. Okay. So we have a wait a second. So we have 2x equals 102. So let's just put this in my calculator. I don't have an actual one because I lost it because I'm a bozo. Is that chocolate on my phone? Oh my gosh, I'm sorry. I went to like a party last night and there's candy there, and I put the wrappers in my pocket because I don't want to litter, and it just kept getting stuck to my phone. So I know that this is gonna be 51 obviously, but I still gotta check because I'm weak. Equals 51. Okay, yeah, 51. So this is gonna be x equals 51, but we're trying to find y though. But I guess these lines right here are supplementary, which means that they're going to add to equal 180. So we got 51, okay. 51 plus 102 equals 153. That can't be right. Is that supplementary? That's got to be a really tiny angle to actually like. Are y and are S and T?
Notice that the 2x degree angle and the 100
Are S and T all like congruent? minus 1. 27? That can't be right. But wait, no, that's not right. That's not right. That's not right. Okay. Yeah, I was completely wrong just now. So if that, okay, I'm gonna say 51 because it's asking for x.
Perfect.
Okay, I'm good. This is the
You need
practice
to tell
problem. I
whether
didn't even
this
need to worry that
argument
much.
is a valid or invalid deduction. If a person is under 62, then he or she is not eligible for Social Security. If Mrs. Marlowe is not eligible for Social Security, then she must be under 62.
Okay, let's just think about this. there's other reasons other than age that might be why they're not eligible or whatever.
First, break the problem up into if then.
I'm gonna say invalid.
Excellent.
Okay.
You need to write the converse of this statement and decide whether it's true or false. Then select the correct answer. If an animal is a peacock, then it has feathers. Remember, the converse is
Okay, so this right here is the if statement, and this right here is the then statement. So we have to flip those around. If an animal has feathers, then it is a peacock. That is not true. So I'm gonna go with this one.
perfect.
Okay. Oh, I hate these ones so much. Sometimes they're fun.
You need to do this proof. You're given that angle O is congruent to angle U, and segment SO is parallel to segment WU. And you need to prove whether segment AO is parallel to segment SU.
I don't know if what are here. Okay, there's not scratch pad for this. Oh crap. That's not corresponding. I don't believe. I think that's alternate exterior angles. Two parallel lines are cut by. Are those parallel? I think they are. I think that's gonna be it. But what would that get us for our next thing? AO. Okay, well that's not. So if those are congruent. Oh gosh, what the frick is that? That's not true. Okay, these are all like. Okay, this could be it. I think these are just alternate exterior angles again though, so I don't think that would be that helpful. Gosh. Is there a hint button somewhere? There's not even a hint button. What the heck? This is hard. What are the options? Okay. So it's all about like angles in the answer. So I'm thinking maybe this. And then tweeness of rays given. That's not given. It has given as an option down here, so it's probably gonna be something that's given. But none of these things are given. So I think it's probably this, and then no, it's not exterior angles. Those aren't corresponding either. What does this have anything to do with the thing? Okay, I think it might be this. I believe that's the transitive property. AOSU. Wait. Transversal? Okay, wait. I was wrong. It's going to be this one, I think, and alternate interior angles. And then it's going to be, oh gosh. It's got to be this, right? I spent way too much time on that. Darn it. Okay, I can try again though. S equals U. How are those not alternate exteriors? What is this? This better not be it. Frick, what did I miss? Oh, it's just this one. Which one was right? Transitive property? Whatever.
True or
Okay.
false? When the if clause and then clause of a statement are flipped around, the converse of the original statement is created.
That should be true.
Excellent.
Okay.
True or false? A good definition is one where both the original statement and the converse are true.
Yes, I have that written down.
Way to go. You need to complete this sentence with the best of the choices given. If two lines form congruent alternate interior angles with a transversal, then the lines blank.
Are parallel.
You got it.
Yeah.
You need to complete this sentence with the best of the choices given. The phrase A if and only if B means both A implies B and B implies A, and it can be written like this.
I think this.
Bingo.
Yeah.
You need to complete this sentence with the best of the choices. Pairs of vertical angles, yes.
All right.
You need to complete this sentence with the best of the choices
Where's
given.
the actual
The
calculation?
blank of a line segment is the point that divides the line segment
Where is
into
it?
two congruent line segments.
See, this is hard because it could be either of these. But I'm pretty sure a bisector can go through any point in the line, and midpoint literally says mid, or like middle. Point. It says point too, so it has to be this, right?
Exactly right.
Okay.
From this given statement, you need to select the definition, property, postulate, or theorem that justifies the proved statement.
Frick, I'm out of copy. Okay. UV and XY. 1 and 2 are supplementary. How do we know that? Those aren't corresponding. And they're, are they two parallel? That this could be it, but I'm gonna keep looking. Okay, I think it's this.
That's right.
All right.
From this given statement, you need to select the definition, property, postulate, or theorem that justifies the proved statement.
What is the substitution property? There's I need an example. That's not helpful. They're not vertical. They're not exactly vertical angles. I think it might be this one.
That's right.
Let's go.
From this given statement, you need to select the definition, property, postulate, or theorem that justifies the proved statement.
Okay. Oh, that would be battery saver. Already? Jeez. I'm not even running that many things. All right. So these are congruent, alternate interior angles. This is a transversal. That would make sense.
You got it.
All right. Okay.
Given that ray BA is parallel to ray DC, you need to select which type of angle this pair is and then tell whether it's congruent or supplementary. And the pair is angle 1 and angle 4.
Are they adjacent though? Where's adjacent? Triangles on the same side of the transversal. They are that.
Bingo.
Okay.
Given that ray BA is parallel to ray DC, you need to select which type of angle this pair is and then tell whether it's congruent or supplementary. And the pair is angle 3 and angle 6.
Okay. So 3, 6, those are alternate interior angles. So they should be congruent.
Exactly right.
Okay.
Given that ray BA is parallel to ray DC, you need to select which type of angle this pair is and then tell whether it's congruent or supplementary. And
Those are a
the
linear
is
pair for
angle
sure.
4 and angle 5.
It's a linear pair.
Way to go.
Yeah, that's what I thought.
Given that segment KL is parallel to segment MN and segment LM is parallel to segment NO, you need to find X. Notice that the 3x degree angle and the
Okay. Okay, here's some actual calculations that need to be done. So 3x equals 96. So let's calculate that real quick. So 96 divided by 3 equals 32. So it's going to be x equals 32. So can I just put x equals 32?
way to go.
Okay.
Given that segment KL is parallel to segment MN and segment LM is parallel to segment NO, you need to find Y.
Okay, well now we literally just got to divide 96 by 2. Wait. Yeah. 96 divided by 48.
That's right.
Yeah, that's what I thought.
If point K is between point J and point P, and if JP equals 4x minus 10, KP equals 2x plus 5, and JK equals 31, then find JP.
What the frick? Okay, I understand. So 31 plus 2x plus 5 equals 4x minus 10, right? Yeah, okay. And then say we move this 2x over here. That's going to make that side 2x. And it's going to make the other side 46. So it's going to be 46 equals 2x. So then we just have to divide 46 by 2, which is 23. Let's put that on the calculator. 40. Nope. Okay, 46 divided by 2. 23. That's what I said, right? Yeah, I said 23. So JP, so we're going to plug that in for JP. So JP was 4, 23 minus 10. We're going to do 23 times 4, 92, minus 10, 82. 82. Okay.
Excellent.
Yeah, there we go. Okay. I thought this lesson was going to be way harder than this. It's probably going to get harder.
If ray CE bisects angle DCF, and if the measure of angle DCE equals x minus 11, and the measure of angle ECF equals 166 minus 2x, then find the measure of angle ECF. Since ray CE bisects
Okay. So x minus 11 is going to equal 166 minus 2x. So in this equation, I'm going to move the 2x to the first side and the 11x to the second side, which will give us 3x equals 100 and like 177, right? It should. Yeah, because it's okay. Yeah, that'll be it. And then we just got to divide 177 by 3. Pretty simple. I just hit my mic. I'm sorry. If my phone would unlock, that would be great. Okay. 177 divided by 3, 59. In other words, x equals 59. So let's plug that in for ECF, which is 166 minus 259. So times 2 equals. So it's 118. And then we're going to do 166 minus 118. 48. Should be 48.
You did it.
All right. Okay.
Angle A and angle B are supplementary. If the measure of angle A equals 6x plus 17 and the measure of angle B equals 3x plus 10, then you need to find the measure of angle A.
So since they're supplementary, they're going to add 180. So 6x plus 17 plus 3x plus 10 is going to equal 180. So you can automatically move this over here to be minus 10. Cross it out over here. This plus 17, we can cross it out. And that's going to be minus 17 over here. And then we can add 6 and 3x, and that's going to be 9x. So 9x equals, and we'll just calculate the rest of that. 180 minus 10 equals minus, nope, 17, 153. So 9x equals 153. So we're going to divide 153 by 9, which is going to be 17. So x equals 17. Plug that in for a, which was 6x plus, so 6 times 17 plus 17, kind of interesting, times 6 equals, oh, okay, plus 17, so it should be 119.
Perfect.
All right, okay.
You need to tell whether this argument is a valid or invalid deduction. Every member of the chess team lost to the machine. Tyler's on the chess team, therefore Tyler lost to the machine.
I mean, yeah. Every member of the chess team lost the machine. I mean, yeah.
You did it.
Yeah, that makes sense. That makes perfect sense.
You need to tell whether this argument is a valid or invalid deduction. If a person is under 18, then that's right.
Yeah.
You need to write the converse of this statement and decide whether it's true or false, and then select the correct answer. If a person is an architect, then he plans buildings and oversees their construction. Bingo.
Yeah, okay.
You need to write
Those
the
I have
converse
trouble with.
of this statement and decide whether it's true or false. Then select the correct answer. If an animal is a raccoon, then it has a bushy tail. Awesome.
Okay, there we go. I'm not going to get this right. I want to get it 100, but I'm definitely not going to get this right.
You need to do this proof. You're given that angle E is congruent to angle G and that segment DE is parallel to segment FG. And you need to prove that segment EF is parallel to segment GH.
I don't see any alternate interiors here, you know? Like, at all. Except for, like, maybe E and G are definitely not alternate interior angles. E and F could be, I guess. Yeah, E and F are. That is definitely not. That's not. E and G, those are not. F and G, those are actually. So I'm gonna go ahead and go with that one. What are the It's always about 2 lines. It's all about 2 lines. Okay. So let's see what the options are. Okay, I think it's gonna be E and F this time. And then, no, wait, because we already had. Okay, E, F. D, E. It's F, G. No, that can't be it. It's gotta be Then again, I don't think this would be it. I'm sorry, my voice is cracked really bad. You know, maybe it is. Whatever. EF equals GH. If 2 lines from the other, that's good. Yeah, okay, this is probably not it. Yep, yeah, I want to go again. Oh no, I got like all of them wrong. Okay, so I'm thinking that means that's probably it. And this one is probably. Oh, it's definitely not that one. That one, and then this one is probably GF. Yeah, this one. Oh, wait, no, it can't be that one. It's got to be this one. gonna be something about like parallel. Okay, but that wasn't it. Given? That wasn't given, so it's not that. DE equals FG. It's not that. It's gonna be some like congruent, maybe? Those are corresponding angles, right? I think this is it. Okay. Oh, frick. What did I miss? The exact same ones? That's great. Okay, let's just frick. So I got like a 90. What did I get? 95? Okay. Oh, well, that's the end of the lesson, so I'm gonna end stream, I guess.